Hello everyone, thanks for coming. So we are going to do a brief review of our first week's lecture on ordinary differential equations. So first, we introduce the concepts of differential equations and distinguish the ordinary differential equation and partial differential equations. So basically, our course mainly studies ordinary differential equations in which a single independent variable, which is often called time, is involved. For PDEs, they may involve several independent variables. For example, if we want to study how heat evolves over time in space, then we would need this heat equation, which involves time variable and space variable. For ordinary differential equations, let's say if we want to track how the position of an object evolves over time, then there's only one independent variable t, and this is an ODE. So there are some important concepts regarding ODEs. So first, we need the initial condition to determine which solution we are looking at. We have ordinary differential equations. We also have ODE systems, which consists of a bunch many coupled ODEs. The order of ODEs, basically the order is the highest order of the derivative we are caring about. So we are going to study first order, second order, and the higher order ODEs. We have linear and nonlinear equations, and note, linear and nonlinear is about the dependent variable y, not about x. Finally, we are going to learn solutions to an ODE. So for some simple first order ODEs, we are going to solve them. For some higher order equations, we will show that the solution exists and in some cases is unique. So first, we study the first order linear ODEs. We can see that the general form for those first order linear ODE looks like this. It is linear in y, but in t, the two functions p and g, they can be anything. So how to solve this? We will need this integrating factor method. So integrating factor is defined as follows. So by multiplying both sides with the integrating factor, we can convert the left-hand side into this form, d mu ty dt. So in this case, we can get an explicit form of y of t. So for those first order linear ODEs, we can always solve them by using this integrating factor method. Next, we study another class of ODEs, which is called the separable equations. So separable equation looks like this: mx dx plus ny dy equals to 0. So we are using the integration curve method to solve those separable equations, which is simply to integrating both sides. So we will get the solution to the separable equations in this form: integrating from 0 to x ms ds plus integrating from 0 to y nt dt equals to a constant c. So constant c is determined by the initial condition. Thanks for listening.